Hello guys, welcome back to Math Zone African Motives. In this platform, we shall be focusing on trigonometry, that is for mathematics N3, for all viewers that we have. So make sure that guys, you are going to join our membership platform. That is a very, very important part so that you can work with more questions as much as you can. And with that platform, you have the opportunity or a chance to ask a question of your choice as long it is for mathematics N3 and so on and so on. It's mathematics N3, mathematics N4, mathematics N5, mathematics N6, all the levels of mathematics that we have. So make sure that you join our membership platform on your YouTube platform. Just click the join button so that you can be able to be part of the membership classes. Okay, anyways guys, let us quickly rush through the questions that we are given. Sorry for the delay introducing a lot of things, but I hope it helped us also as we are moving. So the first part on question 6, we are given to make use of the trigonometric identities. So you are given what to use. You are working with trig identities to prove the following. Okay, so we're given an identity that we are supposed to prove in this case. Okay, so what I'm going to do is to just have this question aside so that we can work this properly together. So this is 6.1. We are given a trig which reads that cos squared 90 plus x everything over. Okay, so just don't mind these guys. Okay, so this is going to be sine 90 degrees minus x. Okay, so we've got sine 90 degrees minus x plus 1 minus sine squared x, like this. Okay, so take note, this whole part is under the division, and we are given that this is equivalent to 1 minus cos x everything over cos x. So I just want you to note something in your syllabus, guys, for mathematics N3. If you are asked to prove whether it's mathematics N3 or it's any level of math, if you're asked to prove an identity, there are two ways that you're supposed to work with. You have the left-hand side of the equation, okay, of the identity that you're given. So we've got our left-hand side, which is supposed to be equivalent to the right-hand side. So there are two cases that can happen. It's not about the calculations that you can do, but there are two cases which can actually happen. The first case is you are going to prove the left-hand side as it is this side. It gives you direct what you have on the right-hand side. It gives you a direct answer. All right, that is the first case. The second case is that you can prove from the left-hand side, the answer that you obtain here is indirect. All right, when I'm saying an indirect answer, it's like that. It's like this. You are obtaining an answer that is not exactly as it is written on the right-hand side, but is the same. It's an answer which is equivalent, but it's not directly written as you can see on the right-hand side. So what you do on that particular question, you work also from the right-hand side so that you obtain the same answer, which we said it was an indirect answer. Okay, so these are the two conditions that can actually happen. So in this case, we do not know which one is going to be the condition. Is it going to be direct or indirect? Let's see. Okay, so what you're going to do is to choose to work from one of the sides. I'm going to choose to work with the left-hand side. So from the left-hand side, we are given cos squared x plus 90. So I'm not going to repeat this. I'm going to simplify direct. Okay, what does it mean when you're given cos squared like that? Let me write it aside here. Cos squared 90 plus x like this can be written as cos 90 plus x. That's cos 90 degrees plus x. Everything in this case like this to the exponent of 2. That is what it means. Okay, so do not confuse this as writing it as cos 90 degrees plus x, then you square it at 90 degrees plus in this bracket. This is wrong. So avoid this in exam. What it means is that the whole of this cos that you see here, the whole of this part is raised to the exponent of 2, just like what I did here. All right, so that is what it actually means. So that's this part of cos squared. Okay, so now let's see what do we have from cos squared plus 90. What is it equivalent to? You can note that from your identities, the equivalent of course is actually in the second quadrant. 90 plus, take note there is a plus x. This x represents an acute angle. So it's actually an acute angle that you're going to obtain in the second quadrant, because we know that we take our angles in this direction, that is in the anti-clockwise direction. So let's say that is where we have our x degrees here. This is your 90. So this is angle of 90 plus x. So in this quadrant, from all students take calculus or from the cast diagram, whatever way that you take it, we can see that the 90 plus x is in the quadrant where sign is actually a positive. We can see that our sign is a positive here. But the cos that we are referring to is a negative, because this quadrant is only for sine, which means cos here is a negative value. So if cos is a negative value, but we have to change this to sine, so which means we are going to write this identity as a negative of sine. So this is going to be like this, guys. It is going to be negative sine of x, but everything must be raised to the exponent of 2. So that is what you're going to have at the end. Remember, cos 90 plus x is equivalent to negative sine x, okay? So make sure that you revise your identities, guys, as much as you can, because that is what you're supposed to use in this case. Okay, anyways, that's what you're going to have here. Remember, 90 plus x is in a bracket, so that's why we are squaring everything. So this is going to be sine 90 in a bracket squared. Okay, that's it. We move on to sine 90 plus x. Sine 90 minus x. Okay, so this is what we have, guys. We must know that sine 90 minus x is equivalent. Sine 90 degrees minus x is equivalent to cos, because 90 minus x is in the first quadrant, because we are saying 90 minus x. So it's in the first quadrant. That's where we can have this angle. But we can note that in this first quadrant that we have, sine is a positive, cos is a positive, tan is a positive. That's why this is just going to remain as a positive cos x. So we're going to have positive cos x. So note this part also. Cos 90 degrees minus x is also equivalent to positive sine x. You must know this. And also you must know that tan 90 degrees minus x is equivalent to cot x. And if it is cot 90 degrees minus x, it is equivalent to tan of x. So you must know this part very, very much. So I think, yeah, these are the ones that we have. Then we've got 1 minus sine squared x. From this part, since we have written this part here in terms of cos x, we're supposed to add something that is the resultant that we have from 1 minus sine squared x. Okay, I want you to get back to your Pythagorean identity. This one is actually there in your formula sheet. So I'm just going to show you your Pythagorean identity so that we can work from there. We can check here from our trigonometry. These are the identities that you're only given. There is this part here, which is our first Pythagorean identity that we have from our Pythagoras theorem. Yes, it created this one and also created this one, but we are working with cos. So we want to have a value that represents 1 minus sine squared x, the one that we are given from this side. So how can we obtain this 1 minus sine squared x that we have? Okay, let's get back to our identity that we are using, which is the Pythagorean identity. We can see that here we've got sine squared theta, which is the one as same as x, and this is same as x. Okay, if you transpose the sine squared to the other side of the equation here, we are going to have this value as a minus. It was a positive, so we're going to have this as a minus, which is 1 minus sine squared x. Remember, we have transposed the sine squared, which means sine squared is no longer there. So we are remaining with cos squared x. So cos squared x is the one that is equal to 1 minus sine squared x. So this is the identity that we are going to use in place of 1 minus sine squared. So we obtained cos squared x. So someone might ask, why are we even changing this identity? Why can't we just leave it in terms of sine? I explained that we are already having cos in the denominator here. So it's better for you to work with a cos the same way that we have on the other part than to work with cos and sine at the same time. So that is why we have to change 1 minus sine squared. Okay, Anyways, let's simplify further and see what you're going to obtain. Negative raised to the exponent of 2, that's a positive any because it's an even number there. And sine to the exponent of 2 can be written as sine squared x. So that's what you're going to have. And in this case, do we have anything that we can do on cos x and cos squared x? Yes, we can factor out cos, because cos is common here. So you can factor out the cos of x. So if I factor out the cos of x, it means I'm dividing. So that's cos x divided by cos x, which is 1, plus cos squared x divided by cos x. There are 2 of them. So if I divide by 1 cos, I'm going to remain with 1 cos like this. So that's what you're going to have. But is this in its simplest form? To cross-check, guys, we have to try by all means to work as much as we can. This is not direct. Let's get back, because on the numerator here, we can check, we can see that we have got sine squared x, which we can change to write it in terms of cos, because here we are having cos. So let's change sine squared x and write it in terms of cos. Remember our Pythagorean identity that we had before? We said here, okay, let me just erase this part. So we want the value that is equivalent to sine squared x this time. Okay, so this is no longer there. What can we do to remain with sine squared? To remain with sine squared, because this is what you want here. You have sine squared here. So what actually happened for you to remain with it means you transpose the cos squared to the other side of the equation. And if it was a positive like this, when you transpose it to the other side, it's going to be negative. So this is going to be negative cos squared theta, which is here we want to write it in terms of x. So it is going to be 1 minus cos squared x. So that's what you're going to have here. So we can write this identity as 1 minus cos squared x in place of sine squared x. I hope we are following these stages. So we said we are going to have 1 minus cos squared x, everything over cos x into 1 plus cos of x. All right. At this stage, someone might think that I've simplified, I'm done, but we are not yet there. What is happening at this moment? In the denominator, there's nothing that we can do because we've already factorized there. But if we are to cross-check on this part, which is the numerator here, we can see that we have an identity that we can actually factorize from our difference of 2 squares. Okay, let me take you back to your difference of 2 squares. Our difference of 2 squares states that a squared minus b squared is equal to a plus b into a minus b. Either way, you can start with a minus b. So here you've got 1 minus cos squared x, of which 1 here is a perfect square because 1 can be written as 1 squared. So this can be written as 1 squared minus cos squared x. So that means we can rewrite this expression in terms of a squared minus b squared. So if it was a squared minus b squared and it gave us a plus b, this is our a and this is our b, which is cos x. So that means we can rewrite this as 1 plus, which is cos x, because we are saying a plus b. Our a here is 1, our b is cos. So it is going to be 1 plus cos of x into a minus b, which is 1 minus cos x. It is going to be 1 minus cos of x. So that's what you're going to obtain from the numerator. So that means we can simplify this numerator as 1 plus cos of x into 1 minus cos of x. So like I said, it can be either way. You can start with 1 minus cos x, is fine. Everything, do not forget the denominator because it's part of your question. So this is cos x into 1 plus cos of x. All right, we have managed to factorize the denominator, but what is happening now? We can see that we have got 1 plus cos x in the numerator, which is the same as 1 plus cos x in the denominator. So these two can cancel. And if they cancel, this is going to remain as 1 minus cos of x in the numerator. Then in the denominator, we're going to remain with cos of x. Okay, so that is the how can we simplify further? Here we can't do anything. Maybe if it is a condition like this, where you can write it as 1 over cos of x minus cos of x over cos of x. That is when maybe the question is written in another way. But at this part, we can say we have simplified to the last part. So let's check now with our part that you are asked to prove, is it the one that you are given? Okay, so we can see this. This is exactly the one. So this one was a direct answer. So like I said, they can be two, indirect and direct. So this one was direct. I think this can actually help us because this one is a direct question. So that's what we had, guys, and we've managed to prove the first part of the question. 6.2, that is, so the first part had 7 marks. That's a lot, guys. As you can see, this first part it had actually 7 marks. Okay, anyways, 6.2 we are given to find the height of a tower. A surveyor sits up his theodolite. So that's a theodolite 150 meters from the base of the tower. He finds that the angle of elevation of the top of the tower is 60 degrees. What is the height of the tower? Okay. Whenever you are dealing with the angle of elevation, whether it's angle of elevation or angle of depression, what you must know is that the diagram that you are supposed to have there is the same. If you are to interpret it either way, it's going to give you the same diagram. Okay, let me just remove this so that we can have our question properly here. So this is what you're going to have for the angle of elevation. We are going to have our diagram in this format. That's a triangle. So if this triangle can be either way, you can have your triangle in this way, or you can have your triangle in this way. Still, it represents the angle of elevation. Okay, where this angle here, theta, that I'm indicating is the angle of elevation, the angle that you're using to look at the top of the pole, or whatever that you're having is a building, is a tree, or whatever that you have. This will be the top of the pole. And it's actually a right angle triangle because we are talking about a horizontal plane and a vertical plane. So this is going to give us a right angle of 90 degrees. Okay, so if we are to take this into consideration, we are given that this height that we have from the base of the tower. So we are given the height from the base of the tower, which is 150 meters. So from the base, this is the tower that we are talking about that they are referring to. So this is actually the tower. Remember, a tower is a vertical, guys. We know this. Okay, so from the foot, that is from this part to this part, that is the base that we are given. So we are given that this is 150 meters. So it's the same thing with this part. Maybe your diagram is like this. This is 150 meters. Anyways, then we are given that he finds that the angle of elevation to the top of the tower, looking at the top, is 60 degrees. What is the height of the tower? Okay, so he was actually looking at the top of the tower. This is the top of the tower. But we say the angle of elevation is the one that is down here. You are looking up from the bottom line. So this is where we have our 60 degrees. So the question is for us to find the height of the tower. So as you can see, guys, this is our tower. So the height that we need, that is this whole length. So we can write it in terms of x. That is the length that we have. So definitely, guys, we need our trigonometrical ratios. Why? Because we are dealing with a right angle triangle. We have got an angle inside this right angle triangle. So to find this height, we have to apply our trigonometrical ratios, which are being taken from SOHCAHTOA. So we have got our SOHCAHTOA. So there are so many ways to have this, but that's the easiest way. So what you're going to do is to name the size that you're given according to the angle that you have of 60 degrees. This is the opposite, okay? It's facing 60 degrees. And where we've got an angle and 90 degrees sitting on this line together, that's the adjacent. So these two angles, they are adjacent to each other. So which ratio that applies opposite and adjacent at the same time? Opposite and adjacent at the same time. That's for TOA, which is tan. So the tan of theta is equivalent to the opposite over the adjacent. So that's the ratio. So you take it that way. So that means the tan of theta, which is the angle of 60 degrees, is equivalent to the opposite, which is the side that we are calculating, which is the height. So you can write it in terms of x, or you can write it as h to represent the height. Over the adjacent, our adjacent, we said here, it's 150 meters. So from this part, we can calculate the value of x, which is representing the height. So this is same as over 1. So from your cross multiplication, you can cross multiply the two. 1 times x, that is x is equal to 150 times tan is 60. That's 150 tan of 60 degrees. So that's you and your calculator at this moment, guys. Okay, let me just change the share screen so that we can have a calculator on the screen here. All right, so I think now we can see everything on my screen. We are going to make sure that your calculator also is in degrees. So this is 150 times 60 degrees. Okay, 150 times 60, which is 259.8, something like that. Okay, so that's what you're going to have. So to 2 decimal place, to 3 decimal, we can just write to 3 decimal place. Yeah, that's 1, 2, 3. This 7 is going to change into 8 because 6 is bigger than 5. All right, so we are going to have it as a 259.808 because remember 7 changed to 8. So that's the height of the tower. So therefore, the height of the tower, is 259.808 meters. Okay, so that's what we had from this typical question. It's very, very important, guys, that you work with these questions. So that was actually 3 marks. All right, on question 6.3, we are given a condition that we are supposed to consider from fig that is given below. All right, so that is the fig that you're given this diagram. So maybe I can just reduce this so that you can see the question in the diagram. So that's the fig there. So given that the crew in a boat noticed the 2 lighthouses, that is A and B. So we've got the lighthouse, which is at A, and the lighthouse, which is at B. Okay, one on either side of the beach. Then the 2 lighthouses are 0.7 apart, as you can see. One is exactly due east to each other. So this one is actually due east to it, which means they are actually saying this line that we see is a vertical line. Okay. Then we are given that taking bearings, we are going to take the bearings from A, which is the boat is 127. So remember that bearing, this type of a bearing is taken from the north. So this is a north pole that we see at this point A. We've got a north pole here, and we've got a north pole here. So which means we're actually having a vertical line. So there's a combination of a vertical line and a horizontal line, of which we know that these two, they meet at 90 degrees. They meet at 90 degrees. So we're given the bearing from A, which is 127, the bearing from B, which is 225. So the question now is calculate how far the boat C is from the lighthouse B. So we need to know the distance. When they say how far, that is the distance. So we need to know the distance that we have from the boat. This is the boat, guys, that we are given here. So this is your boat. So we want the distance boat from C to B. This is the distance that we want to calculate. So you can just say X, or you can write this as A, because we know that from our triangles, the side that is opposite to angle A can be written as A. Side opposite to B can be written as B. Side opposite to C can be written as C. So you can write as A or B. I don't know which way is best for you, or you can just write as X. So how can we calculate this distance? Okay, remember what I told you guys. I told you that these two, they meet at 90 degrees. So if they meet at 90 degrees, let us try to find angles inside the triangle. By doing so, we can know what to use. Is it the trig ratios? Is it cosine rule? Is it sine rule? We have everything there. All right, so what are you going to do? We are going to subtract, because the whole of this angle is 127 degrees. So we're going to subtract 90 degrees from 127 so that we can have the remaining angle, because if we add these two angles, they give us 127. So if we subtract 90 degrees from 127, this is what you're going to, we have 127 minus 90, that's 37 degrees. So that means here we've got 37 degrees at angle A. We can do the same at angle B, because we know that angles at a point, because this is a point, B is a point, angles which complete a complete revolution, they add up to 360 degrees. And we've got from this point to this point is 255, and we also have the 90 degrees. So we are going to add these two and subtract them from 360 degrees. So we're going to add 90 degrees and 255 together, then we can obtain the angle that is remaining. Remember, these angles, they add up to 360 for a complete revolution. So that's 90 plus 255 degrees, which is 15 degrees. So that's what you're going to have in this case. So we're going to have 15 degrees. Okay, so this part is going to give us 15 degrees. Okay, after that, we can calculate the angle at C. Why is it possible now? We know that angles in a triangle, they add up to 180 degrees. Sorry for that. So this is 180 degrees angles in a triangle. So if we add everything, subtract from 180 degrees, we can find the remaining angle. So what are we adding? The angle that is inside the triangle of 37 degrees, and also the angle of 15 degrees inside the triangle, not the ones outside. You add the ones that are inside the triangle. So that's 180 minus the sum of the two, which is 37 plus 15 like this. So this is going to give us 128 degrees. If I and my calculator, we are not mistaken, that's 180. Let me cross check again. That's 37 plus 15 from 180. Yes, that's it. All right, so that's what we have, guys, now at this moment. Remember what we are supposed to calculate. We are supposed to calculate this A, this from C to B. So we are calculating side A, this side A. Okay. Our triangle is having all the angles, they are there. And we only have one side that we are given, which is this of 0.67 kilometers, which is opposite to angle C. Take note, this side is opposite to angle C, okay? If we are to check here, the side that we are calculating, which I referred to as A here, is also opposite to a certain angle, which is 37 degrees. Given this type of a consideration, you are going to apply sine rule. That is the best method to apply in this case, which is the sine rule. Okay, so we are going to apply the sine rule in this case. If you have forgotten the sine rule, there we have it from our formula sheet, where we are given this as sine of A over A is equal to sine of B over B, which is equal to sine C over C. This is our sine rule. But I want you to note something. So I'm just going to, okay, let me write it down here so that I can explain this part. So sorry, guys, for taking long in this video. I want you to understand everything properly. That's the major part. On our formula sheet, we are given it as sine A, which is equivalent to sine of B, which is equivalent to sine of C over C. This formula is best to use because we have got A, capital letter A for the angle. We have got the angle on the top. So this formula is best to use if you are dealing or if you are calculating angles, because the angle is on the top. If you are calculating sines, it's best for you to use it as A over sine of A is equal to B over sine of B is equal to C over sine of C. You just interchange A on top, B on top, C on, just like that. So it's best to use this way if you are calculating sides. If it's best for you to use this way if you are calculating sides. But I'm not saying this formula is wrong. It's fine, but it's best for you to just take it this way. Okay, anyways, I'm just gonna have this part down. So as here, we are calculating A. Okay, we are calculating A in this case, which is A over sine of A is equal to C over, because we just have A and C. These are the ones that are important at this moment. So I'm going to write in a way of calculating sides. Okay, so this is 6.3. Okay, so this was 6.3. So I'm just going to write it this way in this form of sine A. So like I said, you can take even that way. So, okay, you can take the first way, but I'm just going to write it as this for calculating sides. A over sine of A, we've got A and sine A, we've got C and sine C. So it is equal to C over sine of C according to our diagram. If you are using these letters as they are to the diagram, then that's what you're going to have. So our A is the one that we are calculating. So it is going to be A over sine of A, which is the sine of the angle that is at A, and the angle at A is 37 degrees, is equal to C. We have got C, this is C, the small letter C for the side, which is 0.67 kilometers over the sine of angle C, which is the angle that is at C, which is 128 degrees. Okay, so you want to calculate A. What are we going to do now to calculate A? Everything is fine. We are just left with this part. So what can we do to calculate the value of A? We can actually cross multiply, whatever that is best for you. Okay, let me just do it for the way that we all understand. So we're going to cross multiply. A times sine A is 128, that's A. sine 100 of 28, which is equivalent to 0.67 times sine 37. That is sine of 37 degrees. Okay, so to find A, we are going to divide by sine 128 degrees. We divide by sine 128 degrees. So definitely these two are going to cancel. All right, so this one you can work in so many ways. You can even do shortcuts here. All right, so I'm not going to waste my time writing this because we've already divided. Let's just use our calculator at once, guys, because we're going to waste a lot of time now. Okay, so let's put this way, 0.67 by sine 37 degrees in brackets, everything over sine 128 degrees like this. So this is going to give us 0.5116, of which 6 can change this into 2. So this is going to be 0.511512 like this. Okay, this is in kilometers. So that's the distance of C from A, from B, which is 0.512 kilometers. Like I said, you can use it as X. You can use any letter of your choice, guys. It's you guys and your work there. Make sure that you just write something that you understand at the end. Okay, so that's what we had, guys, on question 6.3. This question actually had, okay, I'm trying to reduce this, 5 marks. Okay, so that's what we had. We are going to jump on to question number 6.41. Okay, so let's just remove this part so that we can work this question together properly. All right, on question 6.41, we are given a condition to draw the graphs which represents which are represented by f of x, and the other one is gx, which is equivalent. F of x is 2 sine 2x, gx is sine, it's cos 2x, okay, on the same axis. Okay, so I'm just going to make a sketch in this case so that you can understand what's happening here. For you to draw these three graphs, guys, as you can see, this is a graph for sine, this is a graph for cos. They are taking these graphs from the normal graph of sine, the one that you know. So I just want you to take this as a trick. This is the best trick that you can have. You just take it this way. You know this is the graph for sine, where you know that y is equal to sine of x, which starts at 0, 90, 180, 270, 360. Okay, the same thing for cos. I'm not going to waste much time for this. I just want you to understand this. The same for cos. You know your graph is like this. Okay, let's just redraw this. You must know these graphs, guys, just to sketch them. Okay, so this is 0, 90, 180, 270. Okay, that's 90 here. What happened here? Let me use another pen. Okay, so that is 90 here, 180, 270, and this one is direct at 360. Okay, so the amplitude is at 1, -1. So your values, they are going to be affected at 1 and -1. That is maximum and minimum values. Okay, this is a normal graph that you're supposed to know just to sketch this by head without even using a table values. No. So when you are given now this graph affected on sine x like this, it's now 2x. This is what we have. It's now sine 2x. So I want you to note what this 2x affects on your graph. Okay, this 2x affects the interval that you are using to draw the graph. If you are to check our interval here, it states that, let's be together here, guys, so that we understand. We started at 0 here, 0 degrees, 90 degrees, 180, which means we are separating these by 90, 90, 90. We've got 90, 180, which is difference. There's a difference of 90 here. There's a difference of 90 degrees, a difference of 90 degrees. The same thing for cos. We've got a difference of 90 degrees, a difference of 90 degrees. So what does this 2x affect? It affects that interval that we had. So what are you going to do to find the new interval? Because now we are supposed to have the graph of f of x like this. Our graph now is of f of x, which is equivalent to 2 sine 2x. Don't worry about this 2. This 2 is only affected to say this 1 is going to change into 2. This 1 is going to be -2. That's what this 2 affects this one, that is the amplitude. But this 2x, it affects the interval. So what you're going to do is that you equate that 2x to the original interval. So 2x is equal to, our original interval was 90 degrees. So we are going to equate this to 90 degrees. Then we simply divide by 2 both sides, by 2 both sides. So x now is equivalent to 45 degrees. Our x originally was an interval of 90 degrees. Now we have changed the interval, which means our interval is now a 45-degree interval. What do I mean when I'm saying 45-degree interval? We are going to separate the angles with 45 degree, 45 degree, 45 degree each. So it is going to be easier for us now if we have a table of values for this graph. So I'm just going to sketch a table of values for this graph. Okay, it's just a sketch, guys. Don't mind these lines. All right, so with the value of x that you are going to substitute here, you are going to have the corresponding value of y. So this is your x-axis, this is your y-axis. Okay, so that is what it means. So now we are having an interval of 45 degrees. So this is going to be 0, followed by 45 degrees. So that's 0 degrees, 45 degrees. We move on. If we add 45, that's 90 degrees. If we add 45, that is 135 degrees, like that, and so on and so on. If we add 135, if we add 45 degrees to 135, that is 180 degrees. Okay, so let's check. We are given to do this or to draw these graphs from 0 degrees to 180 degrees. So which means we are limited from 0 to 180. So our values of x are limited to 180. So we are going to end at 180. So that is what it means there. All right, so this is going to be your table of values. So with this table of values, we are going to find the corresponding values of y by using our calculator. We're just using our calculator direct. Make sure that it's in degrees. So it's 2 sine 0 degrees. Okay, 2 times 0, guys, because this is 2x. Okay, let me just write 2 times 0 like that, which is 0. So we are going to obtain a 0 there. We move on. When x is 45 degrees, so it's going to be 2 times 45, of which 2 times 45 is 90, or you can just use your calculator. Okay, 2 times 45 in bracket, that is 2. So you're going to obtain 2. When x is 90 degrees, you do the same, guys. Okay, so you're going to just put 90, or you multiply directly, then you use the value as it is. That's a 0 there. We move on to 135. We do the same. 135, that is minus 2. We do the same at 180. That's 180 here. All right, so we put 180 like this. So that's a 0 there. So having your table of values, it's now easier for you to sketch your graph. So like I said, we are just taking the graph of sine as it is, the one that I showed you on that sketch. So we are starting from 0 to 360. So you're going to have something like this. All right, so that's 0 degrees here. We are going to separate 0, 45 as it is on your table values. So that's 45 degrees, 90 degrees, 135 degrees, 180 degrees. So this is our x-axis, our y-axis. So as you can see, our maximum is at 2, minimum at -2. So that means we can have 1 here, and we can have 2, and we can have -1 here. That's -1 and -2 here. Okay, so that's what you're going to have at the end. Okay, so from this part, we can mark our points. Okay, so the first one, that's 0, 0, that is 0, 0 here. 45 versus 2, so this is 45 versus 2 here. 90 versus 0, that's 90 versus 0 here. 135 and -2, 135 -2, that's down here. 180 versus 0, that's 180 versus 0 here. So now we can just sketch by joining the points. Okay, so this is electronic pen, guys. Very sorry for this, but you're supposed to have a smooth curve more than the one that I'm having here. Okay, so this is what you're going to have. So this is our f of x, which is equivalent to 2 sine 2x. So the same way that we have drawn this graph is the same way that you're going to do for cos. So let's check that one for cos. It's given as f of x is equivalent to cos 2x. Okay, that's gx this time, not f of x, but gx. So we have our gx, which is equivalent to cos 2x. So as you can see, we are having the same scenario here of 2x, which was the same here as 2x. So which means the interval is going to remain as the same of 45 degrees. So all we need is just a table here, but maintaining the same interval because it's 45, just like it's the same as this one, sine 2x, cos 2x, okay? So that's it. We've got our x and our y here. Let's see, 1, 2, 3, 4, something like that. So that's 0 degrees, 45 degrees, 90 degrees, 135 degrees, 180 degrees. So that's what you're going to have at the end. All right, so from this table, guys, we are going to substitute the same way like what we did for sine. So this time we are going to have this as a sine here. So I'm just going to change, delete it here. All right, that's it. Then we put cos. Now it's cos. All right, and we do not have these two this time. So I'm going to delete these two also. All right, we only have these two. So the first one, that's cos 2 times 0, guys. 2 times 0, that's a 0. Okay, so we are going to obtain cos 2 times 0 is going to give us a 1. Okay, so that's a 1. Okay, so that's a 1 here. We move on. Cos 45 times 2, that's 90, or you can just use it as cos 2 times 45. 2 times 45, that's 0 there. So this one is going to be a 0. Move on to 90. Okay, I'm closing here. All right, so that's a 90 there. That's 2 by 90 degrees, which is -1. 135 degrees, cos 1 by 135. 135, that's a 0 here. 180, we do the same on 180. That's 180 like this, which is 1. Okay, so that's what we have. So like I said, we are going to have the same graph as this one for cos. Only the part that is changing is these intervals. So we know this is how the graph of cos looks like. Okay, so we're going to see the same shape, the one that we had, only that it has changed the interval to say now we are going to have, let me just use this one, the red one. Okay, so it's now 0 degrees versus 1. So this is 0 here versus 1. So at 1, that is where we have our point here at 1. Okay, 45 versus 0. So this is 45 versus 0 here. 90 versus minus 1. So this is 90 versus minus 1 here. 130 versus 0. That's 130 versus 0 at this point. 135, sorry, versus 0. Then 180 versus 1, that's 180 versus 1, which is somewhere here. Okay, so you're actually using your graph, but in this case, I do not have that graph, so that's why I'm just using this sketch, but you're supposed to use a graph. So you select a suitable scale of your choice from that graph that you're given, then you draw your graph properly. Okay, so you just select a suitable scale, but I'm just gonna sketch here. So this is how the shape is going to look like this. Then it goes back to this point, like that. Okay, so that's how the shape is going to look like. Okay, so from this graph from these two graphs that we have, is there anything that we are required to do? Let's see. Okay, so this was gx, which is equivalent to cos of 2x. Okay, so let's see what is required now. Okay, so that was 6 marks. Yeah, actually deserves 6 marks. Okay. 6.42. We are now given, use the graph to read off the values of x. Okay, if 2 tan x is equal to -1 from 0 to 180. Okay, if 2 tan 2x is equal to 1. Okay, what actually happened here for us to obtain 2 tan 2x is equal to 1? I want you to see something here. Originally, we had these two graphs that we had, the graph of f of x and the graph of gx. So if we are to take into consideration, we can see that we want to find this value here, 2 tan 2x is equal to 1. We can actually trace out where this identity is taken from. Okay, the first thing that you must come into your mind is where is the point of intersection, because that's where they are going to ask you this question. So let's try to equate this and see if we are going to obtain 2 tan x. Okay, if f of x is equal to gx, that's at the point of intersection. So you're going to take this f of x, which is 2 sine 2x, which is equivalent to gx. Our gx is cos 2x. Okay, so what happened for us to obtain tan 2x? We can even see that if we divide by cos, remember, sine over cos gives us tan. So if we divide by cos 2x both sides, we are going to have sine 2x over cos 2x, of which you know that sine over cos is tan. So it's going to be 2 tan 2x, which is equivalent. Definitely, this will cancel and gives us a 1. So that's where we obtained this value. It was at a condition where f of x is equal to gx, of which this can only happen at the point of intersection. So that's at the point of intersection. So which means you're asking yourself, where do I actually, which position do I have? Where am I actually having the point of intersection? Where these two graphs are equal. That is where these two graphs meet. They meet at this point and they meet at this point also. So what you do is that you take these values direct to the x-axis. The value of x that corresponds at that point is the answer. The same thing here. The value of x which correspond at this point is your final answer. So that is what you're going to do. So in this case, because we are using a plain part, we can't obtain the exact value here. So I want you to use a graph book. Then from that graph book, you take the exact value that is at that point. So it's actually not to say the exact answer that you obtain is the one that you're going, because you are using freehand to draw this graph. So it's actually an approximation that they're going to do. Is your answer in the interval or not? But from the answers that are supposed to be interval, if you have to use your graph, it's supposed to be 13 degrees and 1 or 3 degrees. But these two answers, maybe you can obtain 12,5 degrees, or it can be 1 or 2,9. They will mark that answer because you are using a free hand to draw. It's not like you're having something that is accurate. Okay, so that's what we actually had from this platform, guys, working with trigonometry. From this question paper, it was actually written November 2016, having 23 marks, the whole of these questions. So as you can see, guys, a total of 23. That's a lot of marks in exam. So I want you guys to revise as much questions as you can. And like I said before, make sure that you join the membership classes. If you join the membership, that means you can be able to work with more questions and you have the platform now to ask more questions of your choice from your revisions, from your tests that they give you at different colleges that you are. Maybe you've got some questions that you are doing and you're having challenges. That is the platform for you. So make sure that you join membership and to invite others to this channel, Maison African Motives. It can actually help us to grow as a family. But for now, that's it, guys, for Maison African Motives. Till we meet again.